In question number 10, we've got a point A, comma A minus 2, and then Q is 4 minus 3A, comma negative A. They want us to find the slope, or the gradient, and to do that we're going to need to use the formula y2 minus y1 over x2 minus x1. And even though there's a bunch of letters here, we're just still going to use the formula and plug everything in. Now keep in mind, it doesn't matter whichever one is y2. Whatever we start off is y2, well then that x2 is going to match up. So anyway, I'm going to do a minus 2 minus a negative a, which is the same thing as plus a. And now I'm going to go, and if that was y2, this must be x2. So that's going to be a minus, and it has to be this entire thing. So I put parentheses 4 minus 3a. So now I can simplify a little bit. A plus a is 2a, so that's going to be 2a minus 2. And then here I'm going to distribute the negative 1, so that's going to be a minus 4 and then plus 3a. And again, I can simplify a little bit more here now, and I get 2a minus 2 over 4a minus 4. Now, I can go ahead and factor each the numerator and the denominator, and when I do that, I notice they both have factors of a minus 1. When I divide those out or cancel them, I'm left with 2 over 4, or 1/2. That's going to be my slope. Now in part B, they want to know the slope, or the gradient, of a line that's perpendicular to PQ, and that's easy enough. A perpendicular slope is going to be an opposite reciprocal, which basically means we're going to multiply it by negative 1 and then flip the fraction upside down. The other thing to keep in mind is that perpendicular slopes, their product is always going to be equal to negative 1. So you can always use that to prove that two things are perpendicular, or even find it sometimes. In this case, I know that it's going to be negative 2 because 1/2, I flip it upside down and it's going to be negative. But I can check it. If I multiply 1/2 times negative 2, it equals negative 1. So the perpendicular slope of PQ is going to be negative 2. And then in part C, they want us to find the possible values of A if they give us this length of 10 square root of 5. But keep in mind, we're going to need to use distance formula to do this. And again, just because I've got a bunch of letters instead of numbers, I'm still going to just plug it into the formula. So I know the length, that's 10 square root of 5, and it's equal to the square root of 4 minus 3a minus a squared plus a minus 2 plus a squared. So now all I got to do is simplify. 10 square root of 5 is going to equal, now I'm going to do is I got, let's see, negative 3a minus a, so that's going to be 4 minus 4a squared. And then here I'm going to have an a and an a, so that's going to be 2a minus 2, and that's still squared. Now to get rid of the square root sign, I'm going to square both sides, and then that's going to still keep all this side and the inside, it's going to stay the same. And now I've just got to expand, so this is going to end up being 16 minus 32a plus 16a squared, and this is going to be 4a squared minus 8a plus 4. And it's a quadratic, and all I got to do now is simplify, combine like terms, get everything equal to 0. So here I've got 20a squared, and I got another, let's see, 40a here, and then the numbers, looks like a plus 20. If I subtract 500 on both sides, I'm going to get 20a squared minus 40a, and then that's going to be minus 480. I look at that, and I feel like it's all going to divide by 20, so I try that, and it does. And so 480 divided by 20, that's going to be 24. And so now I've got a quadratic, which is pretty factorable. If I write it out, I'm going to find two numbers that multiply to 24 and subtract to get 2. That's going to be 6 and 4. I find out that a is equal to 6 or a is equal to negative 4. And I make sure that's what they asked, that is, and I'm good to go. All right, thanks for watching.